Hi class, this is the video solution to the third problem in our F equals MA worksheet. This one's asking us questions about weight. Now weight, we talked about that briefly, but weight is just simply the force due to gravity. Right? So the mass of something times the acceleration due to gravity on Earth's surface, that acceleration we've been using as 10 meters per second squared. So these calculations here are just talking about weight, and it's really trying to get us to think about how gravity fits in to weight. As such, I'm not going to draw the free body diagrams for this. It's really kind of a different kind of a question. So let's go and we'll look at it. So on Earth, what do we have? We know that our force of gravity is equal to the mass times acceleration. Mass of our object, what's gravity on Earth? We usually call that G. What's the mass of our astronaut? 60 kilograms. What's the acceleration of gravity at the surface of the Earth? It's 10 meters per second squared. So that tells us that our astronaut would weigh 600 newtons on Earth. But if our astronaut went to the moon, and we have to do the same kind of a calculation, again, we do the same thing. Force of gravity is mass times acceleration, mass times the gravity on the surface of the moon. Here it tells us that the gravity on the surface of the moon isn't 10, it's 1.7. So we're going to take our 60 kilogram mass, multiply it by the gravity on the surface of the moon, the 1.7 meters per second squared. And we're going to see that our astronaut only weighs 102 newtons when she's on the moon. How about if we have an astronaut on Mars? Again, it's the same kind of thing. We're going to find our force. We're asking for weight. That's our force due to gravity. What's our mass here? It's 60 kilograms. What's our gravity on the surface of Mars? It's 3.7 meters per second squared. And so if our astronaut was on Mars, she would weigh 222 newtons. And finally, this last one, it's not meant to be tricky, but I can see where it might be. Here we're talking about if we're in outer space traveling at a constant velocity. Well, there's really two pieces to think about here as we answer this question. And the first one is that when you're in outer space, there is no gravity. Well, if there's no gravity, that means there's not going to be any acceleration. So what does that tell you? That leads you to know that our force is equal to 0. The other thing to think about here is the problem told us that the velocity was constant. Well, the velocity is constant. It also means there's no acceleration. What does that all lead us to? Both of those points to the answer here is the weight of our astronaut in space traveling at a constant velocity would be 0 newtons. Now notice mass, you always have mass. The astronaut always weighed 60 kilograms. But when we talk about weight, that's the force related to gravity. And it have to multiply it by the gravitational force at those areas. And we see that right on the moon, on Earth, 600 newtons, the moon about a 1/6 of that, Mars about a third of that. Right, and then we can go down here. If you're in outer space, there's no gravity, so you have weightlessness. Your mass, or I'm sorry, your weight would be 0.